Hello everyone, my name is Sethi Maunika. I am doing as an intern in Emertxe technology in embedded system. In this internship, we have built a project on the working operation of microwave oven using MPLab, XIDE and PiximLab. Let me introduce my team members. P. Maithili and Y. Chandra. Now coming to the oral explanation of our internship and project, I would like to tell the main aim of the project we have done, that the microwave oven will operate in three different modes as follows. The first one is micro mode, and the second one is grill mode, and the final and last one is convection mode. We developed the code regarding working of oven in these three modes using PIC16F877A. Now coming to the goals of internship, under the duration of this internship, we have gained some basic knowledge on the programming C language, which includes data types, keywords, conditions, loops, and data structures. And also we get briefly about embedded system and microcontroller. And we also learn about embedded programming and also CLCD, characteristic liquid crystal display. Under this banner of micro oven project, we have learned practical and programming knowledge about embedded system. Now we are moving to next slide, which is block diagram of PIC16F877A. This diagram shows the PIC16F877A architecture. PIC16F877A is a 8-bit processor. It contains on-chip flash memory. PIC16F877 is a 14-bit microcontroller and uses RISC architecture. It includes 5 ports. Those are port A, port B, port C, port D and port E. Here PIC16F877A contains input and output ports. Generally these are digital input and output ports. This microcontroller also contains 3 timers, where 2 timers are 8-bit timer and the other one is 16-bit timer. Now we are moving to next slide. This is the stimulator, PIC16F877A microcontroller stimulator used in micro oven. Now we are moving to next slide, which deals about embedded system. Embedded system is a combination of hardware and software to do specific tasks. Here some of the examples of embedded system. Those are smartphone, washing machine, ATM, automatic water sprinkler, disc brake system and etc. Generally the application of embedded systems are time critical. Mainly military applications are time critical. We are also experienced that airbags are time critical in nature. Embedded system different from general purpose computing system. Generally laptop is a general purpose computing system. So here we can alter the application based on our requirement. This is the main advantages of general purpose computing system. Embedded systems are to do specific tasks only. And also embedded systems are low power consumption and also low cost. Here some of the advantages of embedded system. Those are reduces the physical effort and stress, provides security, comfortability and reduces the cost. The general applications of embedded systems are used in education sector, home applications, banking sector, hospital sector, automobile sector and agriculture sector and health sector. Now we are moving to next slide. This is the architecture of embedded system. The main component of architecture of embedded system is core. We are mainly using microcontroller, microprocessor and digital signal processor as the core component. Core components are used to execute the instruction. Here input ports are used to give the user input by using user input ports. Input is the one directional. Output port are used to display the output at the end side. Output is also unidirectional. We are also using the memory, which is used to store and load the memory based on our user requirement. Here the memories are two types, dynamic memory and static memory. We are also using other devices, those are additional hardwares. Additional hardwares are used to do special functions, those are analog to digital converters, timers and etc. In this we are also using communication interfaces. Those are used to communicate between these two devices. Communicating devices are on-board or off-board. In those are wireless or wired communicating devices are many types. Now my teammate will continue the PPT.
My name is Maidli. I am going to continue this PPT. Here I will give the overview of this project. Firstly, we will see about development of code. In development of code, we have some functions. The first one is power on screen function, and next menu display screen function, time display screen function, clear screen function, and set time and set temperature function. In power screen function, it is used to power on the microcontroller. Menu display screen function, it is used to display modes. Time display screen function is used to display selected time. After we select the time, microwave oven starts to run. If we select the pass, it interrupts running process. If we break the process, we can choose stop button. And next step is clear screen function. It is used to clear each mode. And the next final one is set time and set temperature function. It is used to set time and temperature based on our requirements. And the next slide is tools. The tools used in this project are MP Lab X IDE. And next one is PicSimLab. These are two softwares used for coding purpose. And next one is CLCD, matrix keypad, buzzer, fan. MP Lab X IDE for coding and PicSimLab for simulation purpose, and CLCD is used to display working of microwave, and matrix keypad is used for giving input to microcontroller, and the buzzer is used to identify ending or running process of microcontroller. And final fan is used to detect whether the oven is running or not. These are the tools used to detect the working of micro oven. And the next slide represents implementation. In implementation, we have three modes. The first one is micro mode. Here in this micro mode, it is used for heating of food items. After click on key 1, the micro mode is enabled. we have to set time on requirement to start micro mode operation. And the second mode is grill mode. Grill mode is used for frying of food items. We use key 2 to enable the grill mode function. And the next mode is grill mode shows like this. And the next mode is after setting time, we can observe the working process of the grill mode. It shows start, resume, pause, stop options as shown in the presentation. If we select pause, it interrupts the running process by clicking on keys. If we want to again heating, we click on key 4, that is start, or else if we want to stop the process by clicking on key 6. And then coming to the third mode, it is convection mode. By selecting the key 3, this mode is enabled. It is used for deep frying of food items. This mode is different from other two modes. Here we have to set the temperature for preheating purpose. The temperature up to here we have to know about the modes used in the implementation. I'm saying once again, first mode is micro mode, and second mode is grill mode, and third mode is convection mode. Convection mode, the third mode, is different from first two modes, micro mode and grill mode. Here in the convection mode, we set the temperature on our requirements. And the remaining programming execution or implementation of the program is explained by my teammate.
My name is Vai Chandra. Now I am going to explain how the program is executed and to observe the simulation of microwave oven, which is a project of the internship Emertxe technologies. So this is the code we built to run the microwave oven. So here this is the main function, main folder, and this is the header file. So in the header file, I have extracted clcd.h, matrix keypad, timers.h, and I have defined some functions like power on screen, menu display screen, grill mode, micro mode, convection mode, start mode. So these are all I have defined here in the header file. Now coming to the main file, we can observe here the coding. We can see this, the function time display screen function. This function is used to display the time we required to run the microwave oven. So in this time display screen, while the microwave oven is running, we can use the keys start, pause, stop. So this is about the time display screen function. Next, clear screen function. This function is used to clear the screen of previous data to display the present running data. So we will use to avoid the clashes on the screen display using this clear screen function. Next, power on screen function. This function is used to power on the microwave oven. So here when we are starting the simulation after building of code, we can initially observe the powering on of the screen and we will observe power on microwave oven. So next function is menu display screen. This menu display screen is used to display the modes we have. So here the modes are taken as the menu. So we have the modes grill, micro, convention. 3 modes we have. So next, void set temperature function. This set temperature function is used to set the required temperature. This is used in the while running the convection mode. We will use a set temperature function. Next, finally, set time function. This set time function is used to set the time we required to run the microwave oven. So, these are the functions we have defined to build the code. So, now we will see the simulation process. Here, we will go to the simulation. So, when I am starting the simulation, before starting the simulation, I have to build the code. After building the code, I have to open the PixSimLab, and from here I want to load the builded code, and then we will see the simulation. Here, powering on microwave oven. Using the power on screen function, we will get that. Now using the menu display screen function, we will here able to see the micro mode, grill mode, convection mode. Okay guys. Next, to observe the micro mode process, we have to click the matrix keypad 1. So we can see now the working process of micro mode of microwave oven. So here I have to set the time. I will set the time for 30 seconds. No. I will set the time for 25 seconds. No. To clear the 30 seconds, I have to use star key to clearing the 30 seconds time. Okay, now I will set it for 35 seconds. Yeah, you can see the variation. Here the 35 is displaying. So now to start the working, I have to enter the hash key. So now we can observe the micro mode is started running. In this way we can observe that fan is rotating and the timer is running. So in this way we can say that micro mode is started its process in microwave oven. So here we have other options. Pause. If I click the matrix keypad 5 key, then the working of microwave oven is interrupted. You can observe that the rotating fan is stopped and the timer is off. So this pause button is used to interrupt the working of microwave oven. And now to continue the process, I have to click the matrix keypad 4. So here we can see that the fan is rotating and the timer is continuing. And finally, by clicking 6 on the matrix keypad, we can stop the working of micro mode. So here the time up, the fan will stop. This is the process of micro mode. Now we will see the grill mode. By selecting 2, I can observe the working of grill mode. So now here we have to set the time. I will set the time for 30 seconds. Okay, here also same star key is used to clear and hash key is used to enter. So now I will press the hash key. So my grill mode is started working. Here we can observe the fan is rotating and the timer is running. So in this way we can identify that the grill mode is working. So again by clicking pause I can stop the working of grill mode. So in this way again to continue I will click the 4th key. So in this way we can observe that this grill mode is running. So next we'll wait until the time up. Okay, in this way we can observe the grill mode working. So the time is up. Next we will observe the last mode, that is nothing but grill mode. This convection mode. This convection mode is different from above two modes. Here by pressing key 3 I can observe the convection mode. To run the convection mode we have to set the temperature here. Initially I have explained in the code. So now I will set the time for 30 seconds. By pressing hash key, I can start the process of convection mode. So here you can observe that the preheating was started from 180 seconds because I have initially given, I have initially defined in the coding in the set time for 180 seconds to run. So in that way the working will be started in the 180 seconds. Here we will see, wait. While loop. Yeah, here we can see that the while loop function. So as we defined that, now the time is 120 seconds, 180, 117. So we have to wait until it reach the 0 seconds. After that we can set the time and the convection mode will be started. So in the time I want to give some explanation about this PIC16F877A microcontroller board. That is, you can observe here so many parts are internally interconnected. So here we can see that LEDs of port D and port B are connected with port D and port B. So here by using these buttons we can blink the LEDs by oning our port D or port B as required. And also this is a matrix keypad. This is used for to give the input to the microwave oven. And also here we can see the relays, relay 1 and the relay 2. And also here we can see the real time clock. And also here we can see the serial ports. And also heater. And also here we have the 3 interrupt buttons. This is used for interruption purpose. And also we can see the analogs, analog 1 and analog 2. And also the ports, port B, port C, port D. And also we can see the buzzer. So here buzzer, as my teammate has explained about the working of buzzer. And also reset. This reset button is used for to stop the current working program, and it takes to the starting one. So the time reached 8 seconds. 7, 5, 4, 3, 2, 1. Now I will set the time for 5 seconds. By hash key I can enter the convection mode. Here we can observe the fan is rotating and the timer is running. Okay, time up. The convection mode is also completed. So here by using this PicSimLab, we are by building the code in MPLAB XID, we have executed these operations, 3 modes of working operation of microwave oven. Okay, now finally we have learned many informations about embedded systems, and initially we have learned that C programming language In the C programming language, we have learned bytes, interrupts, modes, etc. And in the programming of embedded, we have learned how to execute, how to build the code, and we have observed the simulation and the software. We have built the code. Finally, we have learned so many things. Thank you for your guidance, and the mentors. Thank you for everyone. Thank you.
Thank you.